In a real web application, information is coming from multiple sources. A user input, a mouse click, a server response, or even a hacker who tries to do malicious activities. Okay, that's a rare case, but for sure we need to deal with such data structures. We need a way to describe them, a tool to define this communication. In this episode of Too Long to Read TypeScript, we will learn one of the most popular features, which is called interfaces. I can't wait to show you everything I know about them, so let's get into it. Hello friends, it's Nikos here, and today's video is all about interfaces. So in the previous video we talked about classes, and in that video we said that a class acts as a blueprint for an object. Interfaces are quite similar. So an interface can act as a blueprint for creating classes. So you may be familiar with this concept from other programming languages. For example, Java and C#, they have their own interfaces. Or Swift has protocols, which is pretty much the same concept, right? And TypeScript had support from the very beginning for interfaces. So back then we were using interfaces to define classes. Now the language has been evolved, and an interface is the main way to define data structures. Later on, I will show you in practice how to use interfaces. But first, let's learn their syntax. So I'm here in my text editor, and the first thing I would like to do is create an interface. So we can use the interface keyword and create a track interface. I will use isTrack, and I will tell you later on why I'm using this naming convention, right? And what I would like to do is have some required properties and some optional ones. I have created an isTrack interface which defines the shape of the object. No big surprises here, right? Basically, interfaces have a quite similar syntax with all the other types we've seen so far. And now let's try to use this interface. Let's assume the following JSON structure. It's basically a list of tracks. And what I would like to do is store this in an API response variable. And once I save this, it will automatically convert it to a TypeScript object. And I will collapse this. And now let's try to use our newly created interface to describe the type of tracks. So tracks will be an array of isTrack objects, right? And as you can see, if I assign API response, it will work perfectly fine. So now you will notice that we have an error here, and if I hover over tracks, basically it says that the generous property is missing, and that's because it's an optional property, but I forgot to put the optional operator. Okay, so let's save again the file, and now the error is gone. So let's expand this API response just to review a little bit what we have here. We have an ID, a title, an artist, and these are the three required properties. So if I forgot to pass, for example, the ID, you will see here that I will get a very nice error that ID is missing. It's not a very nice error. It would have been nicer if the type declaration would be here. So here the type error would be a little bit better, but I will revert the code. It was just a demo, but you will also notice that we have this isFavorite property, and TypeScript doesn't complain that our API response has extra properties, and that's okay, right? Because as we've seen from the previous videos, basically we don't want to validate extra properties. So another thing I can have inside my interface is I can define methods if I want. So we can have a method play, which is a void method, and pretty much that's it. Now you will notice that I have an error here because my API response doesn't doesn't contain any play method. That's why I will just leave it as a comment, but this is just for you to understand what kind of implementation, what kind of things we can add inside an interface. So by adding this play method to our interface, the API response becomes incompatible, as we say, because the consumers of this interface must implement this function as well. And this becomes quite useful when you have multiple teams that are working in a very large project, right? And some team decide to name things differently, or they even forget something. So it makes sense to have a common understanding about a specific thing, about a track, for example. So by creating interfaces and storing them in a central place, you are avoiding all this mess. Some teams like to use interfaces both in front-end and back-end. So, for example, they store them in a shared library, and this speeds up their time because one team can start with the implementation of the API, the other team can start with the implementation of the front end, which consumes this API, and they don't need to wait for each other, but they know already what their final objects will look like. And once they integrate their code, there will not be any big surprises, right? Because both sides have an understanding and a common contract about what this track should be. There is a very interesting feature of TypeScript interfaces, which is called declaration merging. And basically this allows you to declare multiple interfaces with the same name. So for example, here we have this isTrack interface, and what I can do is create another interface isTrack. And here I can have an extra property, for example, length, which can be a number. So now, as you can see, TypeScript doesn't complain, right? Because we have 2 times the same declaration for this isTrack interface, and it's perfectly legal. And what TypeScript will do is merge these 2 interfaces, so the result will be something like this. And before I change this code, you will see here that tracks will now expect the length property to be declared, but it's not. That's a very, very small yet important detail about interfaces. I will leave this as a comment here. This is completely different compared to types, because if you have a type track, and if I go here and define another track, boom, then this is a duplication and TypeScript will prevent it. So that's an important thing to remember about interfaces. If you are wondering where or when to use interfaces in your projects, then probably you are not the only one. Interfaces has bugged many developers in the JavaScript ecosystem because, you see, we never had to deal with such classical object-oriented concepts in our code. So now what I would like to do is review with you the most important use cases where an interface will be really useful. And let's start with the most obvious one, classes. Let's modify our code to create a class and implement our isTrack interface. So what I will do is remove this code here and let's create a class. So what I want to do here is to implement the isTrack interface, and I can use the keyword implements and I can pass the name of the interface, and boom. Now TypeScript will complain because my track class doesn't have any of the required properties, so let's go here and declare them. It looks good so far. So as you can see, my track is now compatible with isTrack interface, and if we basically put back our method play, then you will notice that track now is incompatible, so we need to define a play method. Excellent, so my track is again compatible with isTrack interface. So now our track is useless without a constructor, so let's add a constructor here. oops, this must be a number. And now we have a constructor. So again, if we have more properties, like another property, it will still be compatible with our interface, right? Because this interface is the minimum required contract, the minimum required set of properties and methods that are required in order to make it compatible. So two things that are missing from this class is released at and generous, but it's up to us if we want to add them or not. So now you will ask me, okay, then why we define these optional properties? Well, the reason that we define these two optional properties is because we have to make sure that their types will be the correct one. So if we have, for example, here released at, and we specify that this is a string property, then TypeScript will immediately display this error here that we are expecting number to be assigned to released at, right? But here you are having a string, so this will definitely not work. And that's basically how you can use classes to implement interfaces. We can combine multiple interfaces together in the same class. Let me show you how this works. I'm here after my isTrack interface, and this time I will create an interface isPlayable. Now what I can do is I can move my play method to this interface because I can separate it from the original track, right? And together with my play method, I can have a duration. Note that I'm using a completely different name for my interface, so this is basically these are two different interfaces, right? I'm not extending the previous interface. And my track is still compatible with the isTrack interface, even though it doesn't contain a definition for the play method. But what I can do is include the isPlayable interface too. And now I have the play, but probably it will require me to add the duration property. So let's try to do this here and include this in our constructor. There is a typo here. Excellent. So now my constructor has these new properties. You may want to refactor it a bit just to have an object instead of passing all these parameters here. I will not do that now, but what I will do is create another interface. So I will name this interface isFavorable, and as you guessed it, this interface will contain the isFavorite flag together with a toggle favorite method. And let's go here in our track and let's add this interface to our list of implemented interfaces. So we say now that we also support the isFavorable interface. And again, TypeScript will throw an error here saying that, okay, you are implementing this interface, but you're not actually implementing it. So let's go all the way here and add the missing stuff. So what we have is favorite, which is a boolean, and here we need to add it to our constructor as well. And finally, we need to implement the toggle function. I pressed enter, and as you can see, Visual Studio Code already filled everything for me. This is a very simple implementation of the toggle favorite function, and now everything is okay. My track implements all these interfaces without any error. And that's how you can use classes to implement interfaces. So we said that this is one use case when an interface is important and useful. There are other use cases as well. We have covered already one of the use cases, to use interfaces to define the shape of the object structures. So let's do exactly that. If we have a const track, which is a track, then we can assign already track object, and this will be perfectly fine, right? Because these are the three properties that are required and here we basically implement them. So you can use an interface similar to how you use type aliases. And of course, we can use one of the other interfaces. So we can have a playable track, and here we can have a duration and a play method. Pretty simple, right? And another way to use interfaces is when you have functions. So imagine that we have a function that counts the favorite item, so count favorites. This function accepts a parameter items, which is favorable, and it's actually an array of favorable items, and it returns a number, right, with the count. So this can be simply implemented like so. We can filter the ones that are favorite, and we can get their length. So here I'm using is favorable as, again, as a type annotation for my parameter, for my function, right? This is not a part of any class, this is just an irrelevant function, but it's just a very nice demo to show you how interfaces can be useful in more areas, not just classes. The interfaces are very convenient, and the nature of JavaScript is open, right? And sometimes you may have a form that you need to post to the server, and you have a set of fields. Why not creating an interface to handle this the structure? Maybe you are consuming already an API from another source, for example, YouTube or Google Maps API. Why not creating an interface to somehow reflect their API based on their documentation, right? We can also use interfaces in event payloads. For example, the user clicks on a button, there are certain like keystrokes that are pressed. Why not using an interface there to get and read these values? Interfaces in TypeScript can be used as pretty much any other type annotation, right? And to avoid conflicts with their names, the community is used to add a prefix or a suffix to their interfaces. So one common practice is, instead of saying that this is like an interface of a track, is to have some prefixes like is, track, or sometimes I, just an I. So here are a couple of naming conventions you can use to name your interfaces. You can have something like is a person, or you can have I in front of the interface, so it is I person. And this can be completely different from the class person, which implements I person or is person. Another idea is basically to use person. So maybe you are not dealing with classes in your project at all, and you don't want to. Maybe you are embracing functional programming principles. So you don't really have so many classes in your project, and basically this allows you to use interfaces. So you can have functions that pass around these interfaces. So you don't need a specific naming convention. Another idea I've seen is to have names like comparable or, for example, searchable and stuff like that. You can also use the combination of all these naming conventions. It's perfectly fine. The most important thing is to have an agreement with your team and decide which naming convention matches better with your project. And then you should stick to it. You should not change it in every opportunity. And that's all about naming conventions. Think of an interface as a contract. Everyone who has to implement it has to accept the terms and conditions. And this is actually what you're doing. You are setting these terms and conditions. But now you're probably thinking, interfaces look pretty similar with abstract classes, and they are also similar with type aliases. So wait a minute, Nikos. What are the differences and which one we are supposed to use? Well, my friends, that's a very good topic for another video. So make sure you subscribe, because I'm actually preparing it already. As always, you can read everything I just told you in my blog post about interfaces, which also contains all the coding examples. If this video helped you, then don't hesitate to press the thumbs up button. Thank you very much for watching and for supporting my channel. See you in the next one and have a very nice creative day.